So before I go on to continuous joint random variables, I want to introduce this important idea called the marginal. Okay, the marginal PMF for two discrete random variables. Okay, and so we talked last time about the joint PMF. Okay, so the marginal, there are two marginals. This is nothing more than the normal PMF of X, right? So it may be that I give you the joint PMF, and now I want you to tell me, okay, well, what if I don't care about Y? I just want to know about what's happening with X. Well, that's easy to write as saying, well, I care about this value of X, and Y could be anything, which is something that I can get from the joint PMF as adding up all the values of Y, keeping X fixed at this one number that I care about. Okay, so last time we talked about this coin flip example where I flipped the coin 5 times and I counted the number of heads and the position of the first head, and if I didn't get any heads, I said that that position was 0. Okay, and we derived the joint PMF earlier, and I'm just going to draw it here again, where everything is divided by 32. To make this a little bit easier, I'm just going to mark down numbers here, and the numbers here are the same ones that we learned from a previous lesson, so these aren't just coming out of nowhere. Okay, if I add up all these numbers, I'll get 32. Okay, so this is the joint PMF. And now the marginal is saying, okay, suppose I want to know what is just the probability that X equals 3. What would I do? I would add up all of the values along the columns to get just what's going on in X, right? So what I could do is I could just say I'm going to add down the columns to produce just the PMF for X. So I would get 1. Here I get 5. Here I get 1 plus 2 plus 3 plus 4 is 10. 10, 5, 1. Okay? And so this is the marginal PMF for X. Similarly, if I wanted to know just what's happening in Y, I could add along the rows. That is keeping Y constant and just saying I don't care what's happening about X. And what would I get there? Well, I'd get, here are my, 0, 1, 2, 3, 4, 5. What are my PMFs going to be? I'm going to get 1. Adding up these numbers gives me 16. These gives me 8, 4, 2, 1. Okay. So really all these things are divided by 32, right? And this is the marginal PMF of Y. Okay. Now, something to look at here is that, actually I already knew a lot about these marginal PMFs because I know these experiments from just doing them by themselves, right? I know that when I do 5 coin flips, I get a PMF that looks like this, and this is, in fact, a binomial PMF, right? And I also know that if I keep on flipping a coin and I look for the first head, and it's a fair coin, this is like a geometric PMF with p equals a half, right? So this is like 1/2, 1/4, 1/8, and so on, right? And so if I think about it, let me just write this down. X is binomial, and Y is geometric, kind of. And the kind of is that, I know that my geometric PMF usually goes off to infinity. But what I'm doing here is I'm saying, okay, take all this stuff that was off in the infinite tail and add that over to 0 so that I can add up just these 6 numbers to get to 1, right? So this kind of confirms what we already knew about these random variables taken separately. And so that's great. Sometimes you're given a PMF and you don't know anything about the random variables taken separately, and you add them up in the corresponding way to get the PMF. Now, one really important thing to realize is that we can go from the joint PMF to the marginals by just adding, right? That's what we just did. But just thing to keep in mind is that we can't go from the marginals to knowing the joint, right? If I just tell you what's happening in X and Y, that's not enough for you to know what's happening together. And so let me just do a kind of a simple example to illustrate why that's the case. Suppose that I have these two joint PMFs. So let's suppose this is kind of like a uniform PMF in 2 dimensions. And then we have this one. Okay, so if I add down the columns in both examples, I get basically 1/2, 1/2. Same thing in going across the rows, right? So these two things result in exactly the same marginal PMFs, but clearly the joint PMF is very different, right? And in particular, this situation, basically all the outcomes are equally likely. This situation, it's more likely that X and Y have the same value and less likely that they have different values, right? So just telling you about the marginals is not enough for you to know anything about the joint, and that's kind of an important idea. And also we're going to talk shortly about the fact that here, these values somehow are all kind of not related to each other, whereas here, there are relationships between X and Y that we want to capture, and that leads to the ideas of independence and correlation that we're going to talk about in future lessons. Okay, see you next time.